Welcome back, everybody. So today we're going to be taking a look at proving triangles are congruent with ASA and AAS. We are adding to our repertoire of congruence postulates. So if you take a second to think about it, we literally learned SSS, side, 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 SAS, side, angle, side, and now we're going to take a look at two more. Okay, so they shouldn't be overwhelmingly surprising, but let's see how we do with them. Our first is angle side angle, ASA congruence postulate. If two angles in the included side of one triangle are congruent to two angles in the included side of a second triangle, then the two triangles are congruent. So my first triangle is ABC, okay, and my second triangle is DEF. So if angle A is congruent to angle D, use a little arc here, and side AC is congruent to DF. Okay, and then angle C is congruent to angle F. So two arcs here. So look what I've got. Oh, I'm sorry, I apologize. I've got angle, side, angle. The side is directly between my two angles. So if it helps, take your fingers and go like this. You pinch it, and where they pinch is where the side needs to be. Okay. I know it sounds really nitpicky, but it's a big difference compared to AAS. So for right here, angle, angle side, if two angles in the non-included side of one triangle are congruent to two angles in the corresponding non-included side of a second triangle, my two triangles are congruent. So here's my ABC again. A, B, C. And I've got DEF, D, E, F. So angle A is congruent to angle D. C is congruent to F. And then BC is congruent to EF. So again, super nitpicky, but just please notice how the side is not between the two angles. All right, that's my angle side. All right. Number one. Now we have lots of different things here, and my apologies for the no there. You'll see why in a minute. Side, determine whether enough information is given to prove the two triangles are congruent. For my first one, I can see that EG and EG, they're back to back. All right, so that's congruent. That's okay. So I've got a 90-degree angle, and a side, but nothing else. So, no, this would be an example of not enough info. Okay, it's just you don't have enough in order to prove it. Part B, though, I've got my angle PRQ is congruent to angle SQR. Okay, that's my one arc. I've got angle PQR is congruent to angle QRS. That's my two arcs. So, got that going for me. But then I also have by my reflexive property RS in the middle, or I'm sorry, RQ, my apologies. So therefore, I have angle, side, angle. Right? This would be ASA postulate. I know that can be a little confusing sometimes. So something that might help you, and it used to help me when I was doing this, I take a piece of paper and I cover up half of my parallelogram so I can see just the triangle on one side, and so I can see the pattern of ASA. Sometimes when you see that quadrilateral, the four-sided shape there, it throws you off, but good stuff. Okay, now here's the deal for the next few. I mentioned to you guys in class about not having to do proofs, and I'll stick by that. You are not doing proofs. I'd like you to take these notes for proofs, okay, just so you can see them. But, I mean, the big thing I want you guys to get out of the next three problems is look at this picture and see if you can tell me if it's, ASA, AAS, whatever. All right. So number two, here's a good example of a two-column proof. Given the following, all right. So when we do a proof, the first thing you're going to write down is I write down exactly what's given. WY is congruent to XZ, and I realize that's parallel. My apologies. I'm off to a good start. WY is parallel to XZ, and also angle Y is congruent to angle X. My reason for that? Given. Okay. because that is given to me, I'm allowed to say that these two angles, I'm going to label them angle 1 and angle 2, right, are going to be congruent because of alternate interior angles. I can say that angle 1 is congruent to angle 2. Okay, alternate interior angles are congruent. Okay. I really am trying to work on my handwriting. I know it's terrible. Now, the other thing I've got going for me with this problem is these sides are back to back. WZ is congruent to WZ. So I've got reflexive property. All right. So I've got this. So now if I look at my picture, I've got an angle, I've got an angle, I've got a side. I'm allowed to prove these triangles are congruent. WYZ is congruent to ZXW because of AAS postulate. Okay? All right, so you're just trying to recognize that pattern and roll from there. Okay, very nice. On to the back. Great. So, number 3, prove the two triangles congruent. R is the midpoint of QS. All right, and then all this other stuff. So, my first step for a proof is I'm going to copy down what's given. So, it's kind of nice. All you're doing is copying this down. R is the midpoint. QS. Angle QRP is congruent to angle SRT, angle Q, and angle S are right angles, and all of that is given. Alright, now, what do you guys know about midpoint? Well, midpoint is exactly like it sounds. It's the middle point. If R is the midpoint of this entire line, what do you think is true of line segment QR and line segment RS? They have to be the same. So the next thing I can write down here is I can say that QR side length is congruent to RS because of definition of midpoint. Okay? So now I've got this. Now the other thing too is, and this is why proofs are kind of annoying, yes, they tell me they're right angles. What do all right angles equal? 90 degrees. So I'm allowed to say angle Q is congruent to angle S because of definition of right angles. Okay. Well, now look what I have. If I cover one of these up, I have an angle, I've got a side, I've got an angle, ASA. Okay, this time the angle or the side is included between them. So my last step, triangle QRP is congruent to triangle SRT, and my reason for it, ASA postulate. Okay, awesome. Last and final one. Prove the two triangles congruent. Okay, given. So I'm going to copy down what's given. HS is congruent to SM. Angle T is congruent to angle U. This one's a little bit easier. I'm looking for something else here that's congruent. Well, the good news is, you see how these are straight lines? Straight line, straight line. So in the middle here, because that's going on, I know that this angle, angle NST, is going to be congruent to angle USH because of something we learned before in class. Starts with a V, vertical angles. So I can say down here, angle NST is congruent to angle USH now I've got what I need. I've got an angle, side, AAS. So for my last one, I can say triangle TNS is congruent to a triangle UHS, and that's just AAS postulate. Okay. So again, I know there was a lot of proof, and it's good that you guys see it. It really is. I can't stress that enough. It makes you think, keeps your thoughts organized, lets you prove things, back them up. But yeah, keep working with identifying your patterns. Okay, the more practice, the better. As always, keep up the good work and good luck. We're all counting on you.